Hello everyone and welcome. So today we're jumping into a super important chapter for your exams, Chapter 13, Statistics. In this first part, we're going to absolutely master how to find the mean. I need your full attention because this is going to be fun and really useful.
Alright, so here's the game plan. First, we'll refresh that superpower you already have from Class 9. Then, we'll look at what happens when the data gets, well, huge. After that, we'll introduce the hero of our story today, the midpoint. With that, we'll learn something called the direct method, and we'll wrap up by solving a little mystery. Why do we sometimes get two different answers for the same data? Ready? Let's do this.
Okay, first up, your Class 9 superpower. You already know how to do this, but we're about to see it in a whole new light. Think of it as giving your old skills a serious upgrade for Class 10.
So picture this. Your teacher wants to know how the whole class did on a test. Are they going to read out every single person's score? No way, right? Of course not. They'll just give one single number that sums it all up, the average, the mean score. And that is exactly what we're talking about today. Here's the situation. We've got the marks for 30 students. As you can see, the scores are all over the place. Someone got a 10, a few got 40, one student aced it with a 95. Our job is to take all this scattered information and find that one number, the mean. You remember this formula from last year, right? The mean, which we call x bar, is just the sum of everything divided by how many things there are. And that big, kind of weird-looking E symbol, that's the Greek letter sigma. Don't let it scare you. It just means add them all up. It's that simple. Now let's get organized. Look at this table. We've got the marks, which we call xi, and the number of students who got those marks, fi. All we do is multiply them together to get a new column, fi times xi. So, for example, you see that 3 students scored 36 marks. So, 3 times 36 gives us 108. We do that for every single row, and then we add it all up. The total number of students, sigma fi, is 30. And the sum of that last column, sigma fi times xi, is 1,779. And now for the final step, we just plug those numbers into our formula. We take that total, 1779, and divide it by the total number of students, 30. And what do we get? Boom, 59.3. That's it. That's the exact average score for the entire class. See? Pretty straightforward. But, life isn't always that simple. That worked great for 30 students. But what if we had 300 or 3,000? Can you imagine making a table that long? No way. This is where things get interesting, and we need a smarter way to handle lots of data. So in the real world, when we have massive amounts of data, we do something called grouping. Instead of listing every single score, we create buckets, or class intervals. We just count how many students scored, say, between 10 and 25, and how many scored between 25 and 40, and so on. It just makes everything so much more manageable.
And here's what that looks like. It's the same data for our 30 students, but now it's all neat and tidy in these groups. You can see right away that 2 students scored somewhere between 10 and 25, and 7 students scored between 40 and 55. It's much cleaner, right?
Ah, but wait, there's a problem, isn't there? Our formula, it needs a single number for xi, but now we have a range, like 10 to 25. So which number do we pick to represent that whole group? Should we use 10, or maybe 25, or something in the middle? What do we do? And the answer to that very important question is our next big idea. It's all about finding the midpoint. This is the key that unlocks the whole problem. And here's our solution. It's called the class mark. This is the single number that will represent the entire group. And the formula is super easy. You just add the highest and lowest numbers in the group and divide by 2. It's the exact middle. Think of it like a team captain. The captain represents the whole team, while the class mark represents the whole interval. So for that 10 to 25 group, we do 10 plus 25 divided by 2, which is 17.5. That's our new xi.
So now that we have our team captain, our NIZI, for each group, we can go ahead and calculate the mean. And this whole process has a name. It's called the direct method.
Okay, look at this. It's all laid out for us. We have our class intervals, the number of students, fi, and now our new secret weapon, the class mark, xi. And from here, the process is exactly the same as before. We just multiply our fi by our new xi. So for that first row, it's 2 students times the class mark of 17.5, which gives us 35. We do that all the way down, add up that final column, and our new sigma fi times xi is 1860. All right, moment of truth. Let's calculate the mean. We take our total,
1860, and we divide it by the number of students, 30. And that gives us 62. Wait a second. Hold on. The first time we did this, we got 59.3. Now we're getting 62. What's going on here?
And that little mystery brings us to our final and maybe most important section. Let's talk about the difference between an exact answer and an estimate.
So let's put them side by side. On one hand, we have 59.3, the mean from the original ungrouped data. That is the exact answer. On the other hand, we have 62 from our group's data, and that is an approximate answer.
So the big question you should be asking is, why? It's the same 30 students. Why are the answers different? And which one is actually right?
And here's the secret. The difference comes from something we call the midpoint assumption. When we used 17.5 as our class mark, we were assuming that both of the students in that 10 to 25 group scored exactly 17.5. But was that true? Probably not. Maybe one scored 12 and the other scored 20. Because we made that little assumption for every group, our final answer became an estimate, not an exact value.
And hey, don't just take my word for it. Your own textbook states it crystal clear, 59.3 being the exact mean, while 62 an approximate mean. So there you have it. Whenever you calculate the mean from group data, you're finding a really good approximation.
So what's the big takeaway? The most important thing to remember is this. The direct method gives us a very good estimate of the mean. And while it's not perfect, when you're dealing with data for a whole city or a whole country, an estimate is not just good enough, it's an incredibly powerful and useful tool.
Now, the direct method is awesome, but there's always a but, isn't there? What if the numbers were just massive? I mean, multiplying 17.5 by 2 is easy, but what if you had to multiply a class mark like 1,750 by a frequency of 800? The math would get really, really messy and take forever. So, is there an even easier way?
Well, there is. To handle those huge numbers, we have two more brilliant methods up our sleeves: the assumed mean method and the step deviation method. But to learn about those, you'll have to join me for the next explainer, Statistics Part 2. See you then. Hello students and welcome to चलो Chapter 13 Statistics को आगे बढ़ाते हैं। आज हम सीखने वाले हैं कुछ अमेजिंग शॉर्टकट्स मीन कैलकुलेट करने के लिए।
सच बताओ, एग्जाम में लंबी लंबी कैलकुलेशंस देखकर थक जाते हो ना? खासकर जब ग्रुप्ड डेटा का मीन निकालना होता है। इतना मल्टीप्लिकेशन, इतना एडिशन, पूरा टाइम उसी में निकल जाता है, राइट?
देखो, डायरेक्ट मेथड आसान है, नो डाउट। पर जब नंबर्स बड़े हो जाते हैं ना, क्लास मार्क यानी XI और फ्रीक्वेंसी यानी FI, तो कैलकुलेशंस बहुत लेंदी हो जाती है। और जितनी लंबी कैलकुलेशन, उतने ज़्यादा गलती के चांसेस। हमेशा याद रखो, हार्डवर्क से ज़्यादा स्मार्ट वर्क काम आता है।
तो आज का गेम प्लान बिल्कुल क्लियर है। पहले हम सीखेंगे दो ज़बरदस्त शॉर्टकट मेथड्स, फिर हम प्रूफ करेंगे कि तीनों मेथड से आंसर बिल्कुल सेम आता है, और लास्ट में सबसे इंपॉर्टेंट हम डिस्कस करेंगे कि एग्जाम में कौन सा मेथड कब यूज करना है। रेडी हो? चलो शुरू करते हैं हमारे पहले शॉर्टकट से।
Okay, so our first shortcut is the assumed mean method. ये कैलकुलेशन करने का एक बहुत ही स्मार्ट तरीका है।
इस मेथड का हीरो है assumed mean, जिसे हम A से डिनोट करते हैं। बेसिकली हम आंसर का एक स्मार्ट गेस मार लेते हैं। नॉर्मली हम डेटा के बीच में से कोई वैल्यू को A मान लेते हैं। ऐसा करने से होता क्या है? आगे की कैलकुलेशन एकदम छोटी और सिंपल हो जाती है।
प्रोसेस बहुत सिंपल है। स्टेप 1, एक A चूज करो। स्टेप 2, फिर हर क्लास मार्क XI में से A को माइनस करके डिविएशन यानी DI निकालो। स्टेप 3, उसके बाद फ्रीक्वेंसी FI और डिविएशन DI को मल्टीप्लाई करके उनका सम यानी सिग्मा FI DI फाइंड करो। और बस स्टेप 4, फॉर्मूला यूज करके फाइनल करेक्ट मीन निकाल लो।
चलो एक एग्जाम्पल देखते हैं। यहाँ हमने XI वैल्यूज के बीच में से 47.5 को अपना assumed mean A मान लिया। अब देखो, जैसे ही हमने हर XI से 47.5 को माइनस करके DI कॉलम बनाया, नंबर्स कितने छोटे और मैनेजेबल हो गए। -30, -15, सो मच बेटर। फाइनली FI को इन छोटे DI वैल्यूज से मल्टीप्लाई किया, जिससे हमारी फाइनल कैलकुलेशन बहुत आसान हो गई।
और ये रहा इसका फॉर्मूला, बहुत ही लॉजिकल है। सोचो, हमारा फाइनल मीन x बार बराबर है हमारे गैस यानी A प्लस एवरेज डिविएशन। हम बेसिकली अपने गैस को थोड़ा सा करेक्ट कर रहे हैं, एंड दैट्स इट।
तो जब हम टेबल से वैल्यूज इस फॉर्मूला में डालते हैं, A की जगह 47.5, सिग्मा FIDI की जगह 435 और सिग्मा FI की जगह 30, तो कैलकुलेशंस के बाद हमारा फाइनल आंसर आता है
62। सिंपल राइट? चलो अब आते हैं अपने नेक्स्ट लेवल शॉर्टकट पर, द स्टेप डिविएशन मेथड। ये तो स्टूडेंट्स अल्टीमेट टाइम सेवर है। ये प्रो लेवल ट्रिक आपको तब यूज करनी है जब आप नोटिस करो कि सारे डिविएशंस यानी जो DI वाला कॉलम था वो एक कॉमन नंबर से डिवाइड हो सकते हैं, और ये कॉमन फैक्टर h ज़्यादातर क्लास साइज ही होता है।
यहाँ हम कैलकुलेशंस को और भी ज्यादा छोटा कर देते हैं। हम एक नया वेरिएबल UI निकालते हैं। कैसे? बस हर डिविएशन DI को उस कॉमन फैक्टर h से डिवाइड कर दो। दैट्स इट।
इसके स्टेप्स बिल्कुल अज्यूम्ड मीन जैसे ही हैं, बस एक छोटा सा एडिशन है। पहले a और h फाइंड करो, फिर UI कैलकुलेट करो, उसके बाद सिग्मा FI UI निकालो और आखिर में फॉर्मूला में सारी वैल्यूज डाल दो। इजी। अब इस टेबल में देखो इस मेथड का जादू। DI कॉलम में वैल्यूज थी -30, -15, 15, 30। साफ दिख रहा है कि ये सब 15 से डिविजिबल हैं, तो हमारा h हो गया 15। और जब हमने हर DI को 15 से डिवाइड किया तो UI कॉलम देखो, -2, -1, 0, 1, 2। वाह, इतने सिंपल नंबर्स। अब इससे आसान मल्टीप्लिकेशन और क्या हो।
इसका फॉर्मूला भी अज्यूम्ड मीन जैसा ही है, बस एक छोटा सा चेंज है। क्योंकि हमने शुरू में h से डिवाइड किया था तो उसको बैलेंस करने के लिए फाइनल स्टेप में h से मल्टीप्लाई करना पड़ता है। सिंपल लॉजिक।
और जब हम इसमें वैल्यूज डालते हैं, a इज इक्वल टू 47.5, h इज इक्वल टू 15, सिग्मा FI UI इज इक्वल टू 29 और सिग्मा FI इज इक्वल टू 30, तो गेस व्हाट, आंसर फिर से आता है 62। मैजिक राइट?
सो इस सब से हमने क्या सीखा? हमने देखा कि रास्ते अलग अलग हो सकते हैं, पर मंजिल एक ही है।
देखो, चाहे हम डायरेक्ट मेथड यूज करें जिससे आंसर आता है 62, या हमारा पहला शॉर्टकट अज्यूम्ड मीन मेथड, उससे भी आंसर 62, या फिर हमारा प्रो लेवल शॉर्टकट द स्टेप डिविएशन मेथड, तीनों से ही आंसर आता है एग्जैक्टली 62।
तो द मेन टेक अवे ये है कि फाइनल रिजल्ट हमेशा सेम रहेगा। फर्क सिर्फ कैलकुलेशन के प्रोसेस में है, जर्नी में है। ये तीनों मेथड्स अलग अलग मैथ्स नहीं हैं, ये बस एक ही प्रॉब्लम को सॉल्व करने के आसान और स्मार्ट तरीके हैं।
तो अब सबसे इंपॉर्टेंट सवाल, एग्जाम में कौन सा मेथड यूज करना है? लेट्स मेक अ प्रॉपर स्ट्रैटेजी।
ये टेबल आपके लिए एक चीट शीट जैसा है। रूल्स सिंपल हैं। अगर XI और FI की वैल्यूज छोटी हैं तो टाइम वेस्ट मत करो, सीधा डायरेक्ट मेथड यूज करो। अगर वैल्यूज बड़ी हैं तो अज्यूम्ड मीन मेथड यूज करो, कैलकुलेशन ईजी हो जाएगी। और अगर वैल्यूज बड़ी हैं और आपको डिविएशंस में कोई कॉमन फैक्टर दिख रहा है तो बिना सोचे स्टेप डिविएशन मेथड यूज करो। ये आपका सबसे ज्यादा टाइम बचाएगा।
तो अब आप बताओ, अगले एग्जाम में इनमें से कौन सा शॉर्टकट आपकी सुपर पावर बनने वाला है? तीनों को प्रैक्टिस करो ताकि एग्जाम में आप सिचुएशन के हिसाब से बेस्ट मेथड सबसे फास्ट चूज कर सको। गुड लक।
Hello, students, and welcome. Today, we are going to tackle a really important topic in statistics, the mode of grouped data. And trust me, we're going to make it super simple. So here's our game plan for today. We'll start with the basics, do a quick flashback to what you learned back in Class 9, and then, step by step, we are going to absolutely master this new formula. Ready? Let's go.
All right, let's jump into our first section. We're going to take a quick look at what mode actually is. I'm sure this rings a bell, right?
Okay, first things first. A nice, simple question to warm up. So a bowler took these wickets over 10 matches. Just take a good look at this data set. Which number do you see popping up more than any other? Exactly, you've got it. The mode is just that, the value that shows up the most often. Or, to put it in more technical terms, it's the observation with the maximum frequency. Now see what happens when we organize this data into a neat little table. The answer just jumps right out at you. You can clearly see that taking 2 wickets happened in 3 matches, and that is our highest frequency. And so, the mode for this data is 2. Now remember, this was for ungrouped data, which is pretty straightforward. Simple, right? Okay, that was the easy part. But now let's level up. What happens when the data isn't given as single individual numbers, but in groups, or what we call class intervals? So think about this for a second. What if the data is presented in ranges, like 1 to 3, 3 to 5, and so on? How in the world do we find the most frequent value then? We can't just spot it by looking anymore. You see, with grouped data, we can't pinpoint the exact mode directly. We have to do something else first. We need to find the modal class. and that's simply the class interval that has the highest frequency. This is our crucial first step. Now, to solve this problem, we have an amazing, powerful tool at our disposal, a super formula. So let's not wait any longer, let's dive right in. And here it is, our magic formula. Now, I know, it might look a little intimidating at first glance, but please don't worry. We are going to break it down into very, very simple parts. See? That whole big formula is just made up of these 5 simple pieces. L is just the lower limit of our modal class. H is the class size. F1 is the star of the show, the frequency of the modal class itself. Then F0 is the frequency of the class just before it, and F2 is the one right after it. Simple. Okay, enough with the theory. Let's see this amazing formula in action with a real example. After all, practice is what makes perfect, right? So here's our data from a survey of 20 households. Now, what's the very first thing we do? That's right, we find the maximum frequency. Look at the table. Which number is the highest in the frequency column? Yes, it's 8. Because the highest frequency is 8, the class interval that corresponds to it is our modal class. So in this case, our modal class is 3 to 5. Finding this is our most important step, so well done. Perfect. Now that we have our modal class, we can pull out all the values we need for our formula. The lower limit, L, is 3. The class size, H, is just 5 minus 3, which gives us 2. The frequency of the modal class, F1, is 8. The frequency of the class just before it, F0, is 7. And the frequency of the class right after, F2, is 2. And now for the easy part. We just plug all these values right into the formula. We substitute the values for L, F1, F0, F2, and H. Just be careful with your calculations. From here, it's just simple arithmetic. And after we crunch the numbers, we get our answer, 3.286. So that's the mode for this data. And what does that actually mean? It means that in this survey, the most common family size is approximately 3 members. See, it tells a story. So, this probably brings up a question in your mind. We've learned about the mean, and now we know all about the mode. But when should we use which one? Is there a winner? Let's find out. Well, here's the key difference. The mean gives you the average value of the whole data set, like the average marks of a class. The mode, on the other hand, tells you the most popular choice, like the shoe size that sells the most. Ultimately, the situation decides everything. It all depends on what you want to know. If a company wants to know which shirt size to produce the most of, they're not going to calculate the mean, are they? They'll find the mode. So remember, context is king. And now it's your turn to be the expert. I want you to try finding the mode for this next set of data. You have the formula, you know the steps, you can totally do this. Here is the data, straight from exercise 13.2 in your textbook. Go ahead and pause the explainer right here. Apply the formula. First, find that modal class. Then, identify all your values, and then carefully calculate the final mode. Keep practicing, and you'll be a pro at this in no time. Hey everyone, and welcome. Today, we're going to crack 2 really important ideas in statistics, mode and median. By the end of this, you're going to feel way more confident about them. I promise. So let's jump right in and get started. So here's our game plan for today. First, we'll figure out what's trending in our data. That's the mode. Then we'll get a formula to find the exact mode when our data is in groups. After that, we'll do a quick refresh on the median before taking it to the next level. And finally, we'll talk about why any of this actually matters. Sound good? Let's go. All right, first up, the mode. So what is it? Honestly, it's the simplest of the 3. It's just the value that shows up the most often. You know, like a song that's playing everywhere or a video that goes viral. That's the trend. In data, the number that appears most frequently, well, that's our mode. Let's make this real with an example I think you'll like. Cricket. This table here shows the runs scored by some top batsmen in one-day internationals. You can see the runs are grouped into ranges, and the table tells us how many batsmen scored within each of those ranges. So take a good look at that table. Just by looking, can you tell me which group of scorers has the most batsmen? Where is the most action happening? Exactly, you can see it right there. The highest number of batsmen is 18, and they fall into the 4,000 to 5,000 runs group. In statistics, we have a special name for this group. We call it the modal class. Finding this is always your first step. Okay, so we found our modal class. We know the mode. Our final answer is hiding somewhere between 4,000 and 5,000. But where exactly? To pinpoint it, we need a special formula. Let's check it out.
And here it is. Now, I know what you might be thinking. Whoa, that looks complicated, but don't worry. Seriously, don't let it scare you. We're going to break down every single part together, and you'll see it's actually pretty logical.
Let's decode this thing. L is just the lower limit, the starting point of our modal class. So that's 4,000. H is the size of the class, which is 1,000. Easy. Now for the Fs. F1 is the frequency of the modal class itself. That's our big number, 18. F0 is the frequency of the class that comes before it, which is 4. And F2 is the frequency of the class that comes after it, which is 9. See? It's just a pattern. Awesome. Let's put a pin in mode for just a second and switch gears to our next topic, the median. Now, this should ring a bell for you from last year, so this will be a bit of a fun throwback. Now, it's super important we don't mix these two up. Remember, mode is all about what's most popular, the highest frequency. Median, on the other hand, is all about position. It's the value that sits in the exact middle of your data once you've put everything in order. Popularity versus position.
And you remember how this works, right? For simple, ungrouped data, you'd just line up all the numbers from smallest to largest, and then you'd pick the one that's smack dab in the center. That was your median.
Okay, foundations are solid. Revision complete. Now it's time to level up. Just like with mode, we're now going to figure out how to find the median when the data is all grouped together and we can't see the individual numbers. So here's our next challenge. We've got the marks of 100 students. The total number of students, which we call n, is 100. Now, notice something important. 100 is an even number. Keep that in mind. It's about to become very important.
So let's test that memory of yours. When n is even, we can't just pick one number from the middle, can we? We actually need to find two middle observations. Do you remember which two?
You got it. We need the 50th observation, that's n divided by 2, and the 51st observation, that's n divided by 2 plus 1. We find those two, and then we take their average. But wait a minute, how on earth are we supposed to find the 50th and 51st student in this table?
To solve this little puzzle, we need to bring in a new tool, a new superpower for our statistics toolkit. It's called cumulative frequency, or CF for short. And this is going to make finding those middle values incredibly easy. So we just add a new column to our table. And look how simple it is to calculate. You just accumulate the frequencies. The first one is 6. Then for the next one, you do 6 plus 20, which is 26. Then 26 plus 24, which is 50. You just keep adding them up as you go down. And notice, the last CF is always equal to n. Now here's the magic. Look at our CF column. You see where it hits 50? The marks for that row are 28. That tells us that the students from number 27 all the way up to number 50 all scored 28. So our 50th observation is 28. So where is the 51st? Well, they must be the very first student in the next group, which means they scored 29. See? We found them. And now we're at the easy part. We just need the average of those two middle values. So we take 28, add 29, divide the whole thing by 2, and we get 28.5. And that right there is our median. Fantastic job. We've gone through the steps, we've done the calculations, but let's take a step back for a second. Why are we doing this? What do these numbers, mode and median, actually tell us about the world? That median of 28.5 isn't just a random number. It has a very real meaning. It means that it is the exact middle point of the class's performance. About half the students, 50%, scored less than 28.5, and the other 50% scored more than 28.5. It perfectly splits the data in two. So you now have 3 powerful tools in your kit: mean, median, and mode. And that leaves us with one final big question for you to think about. Which of these 3 do you think tells the truest story about a set of data? When should you use one instead of the others? For instance, what if one student got a perfect 100? How would that affect the mean versus the median? That's something to really chew on. Keep practicing, and I will see you next time.
Hey everyone, and welcome back. So, today, we're jumping right into a super important concept in statistics: finding the median for grouped data. I know. It can sound a bit tricky, but I promise you, by the end of this session, you are going to be a total pro. Ready to get started? Let's do this. Okay, so picture this. Your whole class just took a math test. Now, if I asked you what's the exact middle score, the score where exactly half the class scored less and the other half scored more. It's a bit of a puzzle, right? Because we don't have individual scores, we just have groups, like how many students scored between 0 and 10, or 10 and 20. Well, don't you worry, because that's the exact puzzle we're going to solve together today. Now, to find this middle score, we need a special tool, and that tool is called cumulative frequency. It sounds fancy, but in simple terms, it's just a running total. We're literally just keeping a running score of how the data adds up. It's that simple.
All right, have a look at this. This is what we call a less than type table. You see the number of students with marks less than 10 is 5. So how many students scored less than 20? Well, it's the students in the 0-10 group plus the students in the 10-20 group. So that's 5 plus 3, which gives us 8. See how that works? We just keep adding the frequencies as we go down the list.
Now, let's look at the flip side, the more than type table. Here, we start from the total and work our way down. The total number of students is 53, so the number of students who scored more than or equal to 0 is, obviously, all of them, so 53. Now, what about more than or equal to 10? Well, we just take the total and subtract the 5 students from that 0 to 10 group, so 53 minus 5 is 48. And we just keep subtracting as we go down. Okay, so now for our main mission. The very first and honestly the most important step in finding the median is locating the median class. Once you find this, trust me, the rest of the problem is a piece of cake. And finding the median class is super easy. It's just a simple 3-step recipe. Step 1, find the total number of observations, which we call n. Step 2, calculate n divided by 2. And step 3, look for the class in the table whose cumulative frequency, or CF, is just a little bit bigger than their n divided by 2 value. That's it. So let's put that into action. Here's our main table with everything we need: the marks, the frequency f, and the cumulative frequency CF. So what's our first step again? Right, find n. And n is just the total number of students. And as you can see from the table, our total n is 53. Step 1, done. Easy. Moving on to step 2, divide n by 2. So 53 divided by 2 gives us 26.5. Now, this is our magic number. Keep 26.5 in your head. And now for step 3. We're going to go hunting in the CF column for a value that's just bigger than our magic number, 26.5. Let's look. 5 is too small, so is 8, 12. 22 is still too small. But what's the very next one? It's 29. Perfect. That's the first number that's greater than 26.5. And the class that corresponds to 29 is 6070. Boom, that's our median class. Yes, we did it! The median class is 6070. See? The hardest part is over. The rest of the way is smooth sailing, I promise. And here it is, our final weapon, the median formula. Okay, don't get scared. I know it looks a little intimidating with all the letters, but trust me, when we break it down piece by piece, it's actually incredibly simple. So let's do that right now. Let's decode this formula together. L is simply the lower limit of our median class. N is the total number of observations. You already know that. F is the frequency of the median class itself. H is the class size. Now, pay close attention to CF. This is where people sometimes get tripped up. CF is the cumulative frequency of the class that comes before the median class. Not the median class itself, but the one right above it. That's the key, don't forget. All right, enough theory. It's time to take all the values we've identified from our table and plug them straight into the formula to get our final answer. Okay, let's do this. L, the lower limit of our 6070 class, is 60. N over 2 is our magic number, 26.5. CF is the cumulative frequency of the class before our median class, which is 22. F is the frequency of the median class itself, which is 7. And H, the class size, 20 minus 10, is 10. We have all our values. Now, all we have to do is pop each number into its spot in the formula. So 60 goes where L was, 26.5 where N over 2 was, and so on. Look at that. It's not a scary formula anymore. It's just a simple calculation. And once you do the math, drumroll please, the final answer is 66.4. Mission accomplished. We have successfully found the median of our group data.
But what does 66.4 actually mean? Well, this is the cool part. It means that in this class, about half the students scored less than 66.4, and the other half scored more than 66.4. We've found the exact middle point of the class's performance. Pretty neat, huh?
I'm sure you're getting the hang of this, but just to build up that confidence, let's run through one more example really quick. You know what they say, practice makes perfect.
Okay, this time we have data for the heights of 51 girls. So what's our n? It's 51. And what's n half? That's 25.5. Now you tell me, looking at the CF column, which value is just bigger than 25.5? You got it, it's 29. So our median class is 145 to 150. Awesome. You can now use that same formula to find the exact median height.
So now you can find the median score or the median height. But just think for a second. Where else could finding the middle be useful in real life? What about finding the median salary for a certain job, or the median price of houses in a city, or even a batsman's median score in cricket? The applications are absolutely endless. So keep thinking and keep connecting math to the real world. I'll see you next time.
Hey everyone, or welcome back. So all my class 10 friends get ready because आज हम निकलने वाले हैं एक मैथ्स डिटेक्टिव मिशन पर. Seriously? हम अपनी टेक्स्ट बुक्स को छोड़कर मैग्नीफाइंग ग्लास उठा रहे हैं क्योंकि आपके स्टैटिस्टिक्स चैप्टर 13 का एक सुपर इंटरेस्टिंग केस सॉल्व करना है.
All right, let's get started. ये है हमारा mission briefing for today. First, we'll accept our statistics का नया mission. Then we'll dive right into the mystery of the missing X and Y. We'll solve the puzzle step by step, figure out when to use mean, median, or mode, and at the very end, I'll share an ultimate maths trick that connects everything. Ready, team? Let's do this.
So, here's our new mission in statistics. I want you to think of this not just as a math problem, but as a real challenge. For today, you're not just students, you're data detectives. Your job is to find the truth that's hiding between the numbers.
You know, every good detective story starts with a mystery, and our mystery is the case of the missing X and Y. Look, in the real world, data isn't always perfect. Sometimes there are gaps, right? Missing pieces that we need to find, and that's exactly what we're going to do today. So what do we do? What if you're given a data set, but some key information is just gone? Do you give up? Absolutely not. A good detective uses the clues they do have to figure out what's missing.
All right, detectives, take a look at our case file. This table shows a pretty standard frequency distribution. But look closely. In the frequency column, we have two unknown values, X and Y. These are our main suspects. Our mission is to find their exact values.
Luckily for us, we've been given two very important clues to crack this case. First, we know the total frequency, which we call n, is 100. And second, we know that the median of this data is exactly 525. These two clues are the key to this entire puzzle.
Okay, team. We've got our case file, we've got our clues, it's time to put on our thinking caps and begin the investigation. Let's use our mathematical tools to hunt down X and Y.
The very first step in any investigation involving a median is to prepare the data. And that means calculating the cumulative frequency, or CF. Now, the interesting part on this slide is how we build this third column. See, the first frequency is 2, so the CF is also 2. Next, you add the next frequency, 5, to that 2, and you get 7. Then you add X to 7, and you get 7 plus X. After that, you add 12 to 7 plus X, which gives you 19 plus X. Get it? We just keep adding the next frequency at every step, all the way to the bottom.
And boom, we've got our first breakthrough. Take a look at the very last value in our cumulative frequency column. It's 76 plus X plus Y. Now, we know that this final value should always be equal to the total frequency. And what was our first clue? That the total frequency is 100. So that means 76 plus X plus Y must be equal to 100. By rearranging that simple equation, we get this beautiful piece of evidence. X plus Y equals 24. Let's call this evidence number 1. We found a direct relationship between our two suspects. We're getting closer.
Now, let's use our second big clue. The median is 525. The median class is simply the class interval where the median value falls. Since 525 is between 500 and 600, our median class is 500 to 600. This is like shining a spotlight on the exact location of our suspects.
Okay, time to pull out our special gadget, the median formula. Let's make this simple. L is the lower limit of our median class, so that's 500. F is the frequency of that same class, so that's 20. H is the class size, which is 100. And, this is the important part, CF is the cumulative frequency of the class before our median class, which is 36 plus X. Just plug all of these values into the formula, and from there, it's all about careful calculation to find X.
And after solving that equation, we have our answer. X is equal to 9. We've found our first missing value. Fantastic work, detectives! The first part of the mystery is solved. Now that we have X, finding Y is a piece of cake. Remember our evidence number 1? It was X plus Y equals 24. We just substitute X equals 9 into that equation. So 9 plus Y equals 24, which means Y equals 15. And there we have it. Our second suspect has been identified.
So the bottom line is, we found them. X equals 9 and Y equals 15. The missing data has been recovered, case solved. Congratulations, you've successfully cracked the case of the missing frequencies.
So the case is solved, but a great detective's work is never really done. A true master knows which tool to use for which job. In statistics, our main tools are the mean, the median, and the mode. So how do we choose the right one? Let's move on and find out.
Think of these three as your personal detective toolkit. The mean, or the average, is best when every piece of data is important. The median, or the middle value, is what you use when you want a typical value and you need to ignore some really high or low values, which we call outliers. And the mode is the easiest. It just finds the most popular or most frequent item. Let's look at some real-world examples. If you want to compare the average exam scores of two different sections, you'd use the mean. If you want to find the typical salary in a company where the CEO makes a huge amount of money, the median is a better choice. And if a TV channel wants to know which show is the most popular, they'll look at the mode. See? Different tools for different jobs.
Now, as a reward for closing the case so brilliantly, you all deserve something special. I'm going to share a top-secret formula with you. A secret weapon that connects all three of our tools, mean, median, and mode, together.
You might be wondering, is there some secret connection, a shortcut that links all of them? If you know two of them, can you guess the third? Well, the answer is absolutely yes. And this is the secret. This is the empirical relationship between mean, median, and mode. 3 times the median is approximately equal to the mode plus 2 times the mean. This is a powerful master key. If you're running short on time in an exam and you know 2 of the values, you can use this to quickly estimate the third. It's a huge time saver, and it's great for checking your answers.
And with that, I'm leaving you with one final case to solve on your own. Think about the marks you got in your last exams. If you had to describe your performance to your parents using just one value, which would you choose? The mean, the median, or the mode? The answer might tell you something interesting. Think about it carefully. Excellent work today, detectives. I'll see you on the next mission.
हेलो स्टूडेंट्स, वेलकम। मैं हूं आपका दोस्त और आज हम क्लास 10 स्टैटिस्टिक्स के एक बहुत ही इंपॉर्टेंट टॉपिक को मास्टर करने वाले हैं, मीडियन फॉर ग्रुप्ड डेटा। पता है, इसमें मार्क्स लाना बहुत आसान है। बस अगर आप एक छोटी सी कॉमन मिस्टेक से बच गए ना, तो बस रेडी हो ट्रिक को सीखने के लिए। तो आइए सीधे मुद्दे पे आते हैं। ग्रुप्ड डेटा का मीडियन निकालते वक्त एक ऐसी गलती है जो आई एम टेलिंग यू ज़्यादातर स्टूडेंट्स कर देते हैं और उनके वैल्यूएबल मार्क्स चले जाते हैं। जरा सोचो, ऐसी क्या गलती हो सकती है? खैर, टेंशन मत लो। इस सेशन के एंड तक आपको अच्छे से पता चल जाएगा कि वो गलती क्या है और उससे हमेशा के लिए अवॉइड कैसे करना है। देखो, मीडियन के हर प्रॉब्लम को सॉल्व करने के लिए ना बस एक ही मास्टर फॉर्मूला है। अगर आपने इस फॉर्मूला को और इसके पार्ट्स को ठीक से समझ लिया तो आई प्रॉमिस कोई भी क्वेश्चन आपको परेशान नहीं कर पाएगा। तो चलो देखते हैं ये फॉर्मूला क्या है। ये रहा। हाँ, आई नो, पहली बार देखने में थोड़ा कॉम्प्लेक्स लग सकता है। इतने सारे लेटर्स हैं, L, N, C, F, F, H, बट ट्रस्ट मी, हर लेटर का एक बहुत ही सिंपल सा मतलब है। चलिए इन सब को एक एक करके डिकोड करते हैं, बिल्कुल एक डिटेक्टिव की तरह। तो ये है हमारे फॉर्मूला के बिल्डिंग ब्लॉक्स। L है मीडियन क्लास का लोअर लिमिट, N है टोटल फ्रीक्वेंसी यानी सारे ऑब्जर्वेशंस का सम, F है मीडियन क्लास की फ्रीक्वेंसी और H क्लास का साइज। पर सबसे इंपॉर्टेंट, CF को ध्यान से देखो। ये क्यूमुलेटिव फ्रीक्वेंसी है, पर मीडियन क्लास की नहीं, उससे ठीक पहले वाली क्लास की। बस यहीं पर ज्यादातर कंफ्यूजन होता है, इसको दिमाग में फिट कर लो। चलिए, अब थ्योरी बहुत हो गई,
इन सब कॉन्सेप्ट्स को एक एक्चुअल प्रॉब्लम पे अप्लाई करके देखते हैं। ये है आपकी टेक्स्ट बुक का क्वेश्चन नंबर 4, जहाँ हमें 40 पत्तियों यानी 40 लीव्स की मीडियन लेंथ निकालनी है।
ओके, स्क्रीन पर देखिए, ये है हमारा डेटा। एक कॉलम में लेंथ दी हुई है मिलीमीटर्स में और दूसरे में नंबर ऑफ लीव्स, जो कि हमारी फ्रीक्वेंसी है। गोल सिंपल है, इस डेटा से मीडियन लेंथ फाइंड आउट करनी है।
लेकिन रुको, फॉर्मूला अप्लाई करने की जल्दी मत करना। इस डेटा में एक ट्रैप छुपा हुआ है, एक जाल। और अगर आपने इसे नोटिस नहीं किया ना तो पूरा आंसर गलत हो जाएगा। जरा क्लास इंटरवल्स को गौर से देखो, क्या आपको कुछ अजीब दिख रहा है? स्पॉट कर पाए प्रॉब्लम? ये देखो, पकड़ में आ गया। पहली क्लास 126 पर खत्म हो रही है, लेकिन अगली क्लास 127 से शुरू हो रही है। बीच में गैप है, मतलब ये डेटा कंटिन्यूस नहीं है। और मीडियन का फॉर्मूला सिर्फ और सिर्फ कंटिन्यूस डेटा पर ही अप्लाई हो सकता है। यही है वो ट्रैप, यही है वो बिगेस्ट मिस्टेक जिसके बारे में मैंने शुरू में बात की थी। तो इस प्रॉब्लम को फिक्स कैसे करें? रूल बहुत सिंपल है, एक छोटा सा हैक। हर क्लास की लोअर लिमिट से 0.5 माइनस कर दो और अपर लिमिट में 0.5 प्लस कर दो। दैट्स इट। इतना सिंपल सा काम है इस डेटा को कंटिन्यूस बनाने के लिए। ओके, सो ट्रैप को हमने पहचान लिया और डेटा को फिक्स भी कर दिया। अब हमारा फाउंडेशन बिल्कुल सॉलिड है। अब हम रेडी हैं इस प्रॉब्लम को स्टेप बाय स्टेप सॉल्व करने के लिए। लेट्स डू दिस। तो ये रही हमारी नई करेक्टेड टेबल। अब अगला स्टेप, क्यूमुलेटिव फ्रीक्वेंसी यानी CF कॉलम बनाना। ये बहुत आसान है, बस फ्रीक्वेंसीज को एक के बाद एक ऐड करते जाना है। पहला 3, फिर 3 + 5 = 8, फिर 8 + 9 = 17 एंड सो ऑन। एक चीज नोटिस करना, जो लास्ट CF होगा वो हमेशा टोटल फ्रीक्वेंसी n के बराबर होगा, जो इस केस में 40 है। चलो अब मीडियन क्लास ढूंढते हैं। सबसे पहले n/2 निकालो, यानी 40/2, जो हुआ 20। अब CF कॉलम में देखो, 20 से जस्ट बड़ी वैल्यू कौन सी है? राइट, वो है 29। तो इसके सामने वाली क्लास 144.5 से 153.5, यही है हमारी मीडियन क्लास। चलिए अब हमारे फॉर्मूला के लिए सारी वैल्यूज इस टेबल से निकालते हैं। n/2 है 20, हमारी मीडियन क्लास है 144.5 to 153.5, तो L यानी लोअर लिमिट हो गया 144.5। उसी क्लास की फ्रीक्वेंसी F है 12 और CF याद है ना, मीडियन क्लास से पहले वाली क्यूमुलेटिव फ्रीक्वेंसी यानी 17, और क्लास साइज H है 9। बस सारे पजल पीसेस हमें मिल गए। तो सारे पीसेस रेडी हैं, अब बस उन्हें फॉर्मूला में सही जगह पर फिट करना है। L की जगह 144.5, n/2 की जगह 20, CF की जगह 17, F की जगह 12 और H की जगह 9। अब जब आप इसको आराम से केयरफुली कैलकुलेट करेंगे, आपका फाइनल आंसर आएगा 146.75 मिलीमीटर्स, और यही है हमारी मीडियन लीफ लेंथ। तो इस पूरे प्रोसेस को हमेशा याद रखने के लिए और एग्जाम में वो ट्रैप वाली गलती कभी ना दोहराने के लिए मैंने आपके लिए एक फाइनल चेकलिस्ट बनाई है। इसे हमेशा फॉलो करना, ओके? तो इसको सिंपल से 4 स्टेप्स में याद रखते हैं। स्टेप 1, सबसे पहले हमेशा चेक करो कि क्लास कंटिन्यूस है या नहीं। अगर गैप है तो 0.5 रूल यूज करो। स्टेप 2, CF कॉलम बनाकर n/2 की हेल्प से मीडियन क्लास फाइंड करो। स्टेप 3, सारे वेरिएबल्स L, n/2, CF, F और H को आराम से आइडेंटिफाई करो। और स्टेप 4, वैल्यूज को फॉर्मूला में डालो और सॉल्व कर दो। बस इन स्टेप्स को फॉलो करो एंड यू विल नेवर गो रॉन्ग। और आखिर में, ये लाइन मैं नहीं कह रहा, ये आपकी NCERT टेक्स्ट बुक में ही लिखा हुआ एक स्पेशल नोट है। इसमें साफ साफ लिखा है कि मोड या मीडियन निकालने से पहले ये ज़रूर चेक कर लेना चाहिए कि क्लास इंटरवल्स कंटिन्यूअस हैं। तो अगली बार जब भी आप स्टैटिस्टिक्स का कोई भी सवाल सॉल्व करें, इस कंटिन्यूटी ट्रैप को ज़रूर याद रखिएगा।